Hi physical science students, welcome to the next video in our equations of motion series. This is video 3, looking again at vertical motion, but this time we're going to throw things down. So last time we were just looking at dropping things, this time we're going to throw things down. How does throwing things down change things? Well, it means that we have an initial velocity. It means that wow, that's gone crazy. It means that u does not equal 0, and that changes things because it means that we just need to approach it slightly differently. So in the previous section we just dropped things, so u is equal to 0 and the object fell like so, but in this case we're going to throw things down so they have a value of u. Let's say it's 5 meters per second. Okay, and that means the object will then fall under the influence of gravity, but it will end up, these two objects will have different impact velocities, even though they both accelerated due to gravity at the same rate. But the only difference being that this one starts off with an initial velocity. A way of thinking about it is it's exactly the same as this, except if we dropped it up here where u equals 0 and the object falls, and at this point here it would actually have a value for u, let's say 5 meters per second, and then continues on its motion down to here. Okay, and so these two objects would fall at exactly the same rate and impact with exactly the same velocity, even though this one was dropped and this one was thrown. We're just looking at it a little bit differently. But again, we're using the equations of motion because it's falling under the influence of gravity, so it's uniform acceleration, so we can use the equations of motion to analyze it. We don't ask these questions too often, but you just have to be aware of them. We could, for example, ask what is the velocity at this point here, and you would have to analyze it using the equations of motion, which is just a variation of this. So hopefully we'll do a couple of examples and we won't confuse you too much. Let's have a look. So here we have an example, zero gravity research facility at NASA. They have a 150 meter high tower. They drop things down it, 1 meter sphere for example. This time the sphere is projected downwards, so it has an initial velocity. So let's write down what we know. U, V, A, S and T. Let's change the color. And so the initial velocity is not 0, it's 5 meters per second down, because we're throwing it down. And so let's make that negative, because we know that it's going to accelerate due to gravity, which is minus 9.8 meters per second to the minus 2. What else do we know? So we've used that one. We also know the distance. So that's going to be minus 100 let's just get rid of that one. Come on. Let's just minus 150 meters. And so our equation that we might use to find t, looking at this, is you might be tempted to use the equation S equals ut plus half a t squared. However, the problem here is that because u is not 0, we've got two t's, and those two t's are going to remain unknown. Now if you do an advanced maths, you may have been introduced to either factorization or the quadratic equation, which you could use to solve this. However, I recommend that you don't, because it's too fraught with danger. In terms of the quadratic equation, you more than likely make mistakes. So to do a little bit of lateral thinking, the way to solve these questions where you're after t but you've got two t's unknown is to go in a roundabout sort of way and work out v first. And once we find v, we can then very simply find t. And the equation to find v given these ones is v squared equals u squared plus 2as. And putting the numbers in, let's just work our way through this. That's going to be minus 5 squared plus 2 minus 9.8 minus 150. Let's not make that 1.5. And so v now becomes, I'm going to show you just a few lines of working here just so you get the idea of what we're doing. So these two minuses cancels, that becomes positive, so v is going to be the square root, and the square of a negative is positive, so that's going to be the square root of 2,967. v is going to equal 54.45 meters per second to the minus 1. Now we've thrown it down, gravity's acting down, so it's going to be down. And so the only trick there that we need to recognize is that this is going to be negative because it's down. So now let's work out the negative next part of it. So v equals u plus at, because we are after the time, and so this is going to be minus 54.45 equals minus 5 plus minus 9.8 bracket t. So we're going to be minus, the opposite to minus 5 is adding it. Write this a little bit here. 54.45 minus 5 equals minus 9.8 t. Okay, now because it's a minus, that's the same as adding, and so we end up with minus 49.45. Good idea to do that in your calculator. Equals minus 9.8 t. Therefore, we can say that t equals minus 49.45 divided by minus 9.8. t is equal to 5.04 seconds. And so it's a fairly long way of calculating t, but we're less likely to make mistakes if we're careful. So that's how to do that one. Let's get rid of that. Let's move on to the next question. Okay, in this one we have a balloon moving downwards at 30 meters per second, drops a sandbag at a height of 500 meters. What time will it take? So there's our time question again, and what will be the speed that it hits impacts with. And so if we look at what we're given u equals minus 30 meters per second to minus 1, v equals unknown, s equals minus 500 meters, a is our acceleration due to gravity, minus 9.8, and t is what we're actually finding. T and v are what we're actually finding. So again, in this case, it's better off to work out part B. Find v first and then find t. Otherwise we're going to run into the quadratic equation. So v squared equals u squared plus 2as would be our formula. We put in the numbers, being fairly neat with our setting out. There's our line to show us we know what we're doing. We expand it Therefore V is going to equal the square root of 10,700. V is equal to 103.4 meters per second to the minus 1. But because we've gone down, that would be a negative. Okay, and now we can work out A by using V equals U plus AT minus 103.4 equals minus 30 plus minus 9.8 T. We have minus 103.4 minus 30 equals minus 9.8 T. Put this in brackets just so that you can realize that minus and minus is the same as adding 30, and that's why it becomes minus 73.4 divided by minus 9.8 equals T. Therefore T equals 7.5 seconds. There you go. How's that? Okay, so hopefully that didn't lose you. Sometimes it doesn't matter if you work out B before you work out A. You're less likely to make mistakes doing it this way. You can try doing it using the quadratic equation. That's your choice. Alright, let's move on. And in the next video we're going to deal with the situation of when we throw things upwards. Cheerio!